For this next section, we're going to graph a quadratic equation out of standard form. And to do that, we're going to look at the equation for a quadratic in standard form, which is y equals a times x squared plus bx plus c. As always, our a value is going to be our stretch, compress, or reflect. And again, a is greater than 1 represents a stretch, a is less than 1 represents a compression. And then if a is negative, we're going to have a reflection across the vertex. And again, remember that it is possible to have both a reflection and either a stretch or a compress, but we cannot have a stretch and a compression at the same time. Now, B indicates that we're going to have movement horizontally along the x-axis. So it's going to move either left or right based on what that number is. Then C is always going to be the y-intercept. So we will always know at least one value heading into our graphing. Next up, we've got the axis of symmetry, and the axis of symmetry formula for standard form is negative b over 2a. So we're going to take that b value, multiply it by a negative 1, and then divide that result by 2 times the a value. Just a reminder is that the axis of symmetry is the line that runs vertically through the vertex of either an absolute value or a quadratic graph, and the graph can be folded onto itself over that axis. So when we graph a quadratic out of standard form, these are the rules we're going to follow. The first thing is we're going to identify that a value and any stretch, compress, or reflection that goes along with it. Then we're going to locate the c value, and we know that the c value is the y-intercept. So this tells us 1 point on the graph, which is going to be 0, c. Then our third step is to factor the equation to find the x-intercepts. So the factors, again, are going to be the x-intercepts. What we're going to have to do is apply the zero product property to solve for x, but that's a fairly simple operation. Any x-intercepts represent points on the graph, and those are going to be represented by a number, then 0. So it's going to have 0 movement vertically. Then the next thing we're going to do after that is we're going to find the axis of symmetry. And to find the axis of symmetry out of standard form, we're going to use the formula negative b over 2a. Then once we've done that, we're going to substitute the axis of symmetry into the original equation, and we're going to solve that, and that's going to give us the y value of the vertex. So the vertex is going to be the axis of symmetry, comma, whatever y is when we plug the axis of symmetry into that equation. Then step 6 is if the graph opens up, there's going to be a minimum. If the graph opens down, there's going to be a maximum. And this is again based off of the value of a. Is it a positive or a negative? Then step number 7, the domain of a parabola is always all real numbers, or we're going to go negative infinity to infinity. Number 8, a graph that opens up has a range greater than or equal to the maximum or minimum. A graph that opens down has a range that is less than or equal to the maximum. Then in step 9, create a chart with 5 values for x, 2 greater than and 2 less than the axis of symmetry. And then finally, step 10 is going to be to graph. So let's go ahead and put all this together with problem number 2, which is graphing a function of the form y equals ax squared plus bx plus c. And the one that we're given to graph is y equals x squared plus 2x plus 3. So again, I'm going to rewrite the equation, and then I'm going to find the a value. The a value is 1, so that means that our stretch, compression, or reflection is none. Then I'm going to locate that c value, and that c value is 3, so that means that my y-intercept is at 3. And then the x-intercepts, we cannot factor 3 to give us 2. So that means that we would need the quadratic formula, which we have not covered yet. So we're going to leave the x-intercepts as they are with none, or needs the quadratic formula. The axis of symmetry, we're going to take negative b, so negative times 2, which is negative 2, over 2 times a, which is 2 times 1. So we get negative 2 over 2, or negative 1. So our axis of symmetry is at x equals negative 1. We're going to plug that into the formula. We get negative 1 squared plus 2 times negative 1 plus 3. So negative 1 squared is 1. 2 times negative 1 is negative 2 plus 3. So we get 1 minus 2 plus 3. So 1 minus 2 is negative 1, plus 3 is 2. So that means that our y value for the vertex is at 2. The vertex then is negative 1, 2. Then based off of that vertex, we find out that we have a minimum at y equals 2 because our graph is going to open up because the a value is positive. And then the domain is always going to be all real numbers or negative infinity to infinity. And then the range is going to start at 2. And since the graph opens up, it's going to go upwards. So you can see that we've already got 2 points on our graph. We've got the vertex at negative 1, 2, and we've got the y-intercept at 0, 3. So we need to choose 2 values for x on either side of the vertex, and the easiest values will be negative 3, negative 2, and then since we've already got 0, we'll plot 1. When we run those calculations through, we find that negative 3 gives us a value of 6, negative 2 gives us a value of 3, and 1 gives us also a value of 6. So now we have enough information to create our XY chart. We'll create that XY chart and then go ahead and graph all of those points that are on it, connect those points with a line, and there's your graph for y equals x squared plus 2x plus 3. In problem number 3, we're going to be asked to convert from standard form to vertex form. Now, what you've got to think is, what do I need in order to be able to do vertex form? You need an A, and then you need the vertex, which is going to be h and k. So how do we find the vertex in standard form? Well, to find the vertex in standard form, we use negative b over 2a. So we're going to go ahead and plug those values into that formula. So when we do negative b over 2a, we get negative times 10 over 2 times 2. So negative 10 over 4, which is then equal to negative 5 over 2. So that gives us the axis of symmetry. Then we can take the axis of symmetry and plug that into the original equation to then find out what is the y value of the vertex. So we'll go ahead and do that. So we get y equals 2 times negative 5 halves squared plus 10 times negative 5 halves plus 7. So negative 5 halves squared is 25 over 4, and 10 times negative 5 halves is negative 25. Again, you can do this one of 2 ways. You can divide the 10 by 2 and then multiply by 5, or you can multiply the 10 and the 5 and then divide by the 2, and then you'll tack on your negative, and that gives you the negative 25. Now we still have to deal with the first fraction, so we've got 2 times 25 over 4. 2 times 25 is 50, so over 4, 50 over 4. 4 doesn't go into 50, so we'll need to reduce that fraction down to 25 over 2. Now, since we need to add all of these things together, we're going to have to take our b and our c values, or what was our b and our c values, and we're going to have to change those into fractions with a denominator of 2 in order to be able to add all this together. So that's going to give us 25 over 2 minus 50 over 2 plus 14 over 2. When you take those and add them together, you end up with negative 11 over 2. So that is the y value of the vertex. So now we've got the x value of the vertex, we've got the y value of the vertex. We just need to go back and locate our original a value, which is 2. So we take our general form of a quadratic equation, y equals a times x minus h squared plus k. We plug in 2 for a, then we plug in negative 5 halves for h, and we plug in negative 11 halves for k. When we work all that out, we end up with 2 times x plus 5 halves squared minus 11 over 2, and that's our solution converting from standard form to vertex form. Now our last question has to do with interpreting a quadratic graph. We're given the arch of the New River Gorge Bridge can be modeled by the equation y equals negative 0.000498 x squared plus 0.847x, where x and y are in feet. How high above the arch is the road deck? How long is the section of the bridge above the arch? So what we want to do is we want to find our vertex, and the vertex is going to give us the height of the road and then we can multiply the x value by 2 to then find the road deck. So to find the length of the bridge, we first got to find out what is the x value of the vertex. So we're going to use our axis of symmetry formula, negative b over 2a, and we're going to plug in all of our information into this formula. So we get negative 0.847 over 2 times negative 0.000498. And of course, you're going to need a calculator for this part, and we're going to get that it's approximately 850 feet. Now, since the axis of symmetry shows you the bridge, or the middle portion of the bridge, we would need to multiply that by 2 to tell us the length of the road deck. So 850 times 2 is going to give us approximately 1,700 feet for the road deck. The next thing we'll do is we'll substitute our axis of symmetry into the original equation to find the y value of the vertex. Again, you're going to need a calculator for this portion, but once you've multiplied all that through, you're going to find out that it's approximately 360 feet. So the road deck is approximately 360 feet above the foundation of the arch, not above the river, but above the foundation of the arch.